Find the perimeter of the larger triangle. All right. Let's see. I have 42, 26. Uh-oh. This chunk is 11. But I don't have that part right there. Well, what I have is I have two right triangles inside a larger right triangle. Maybe this might not even be right. Who knows? It may not be. It doesn't matter. All I know is that this is a right triangle, that's a right triangle. So what I can do is I can find this missing side right here by using Pythagorean theorem. Once I find that missing side, I could use Pythagorean theorem again to find that guy. Add all four of these sides up, and I have myself my perimeter. So let's do that. Let's find this missing side right here using Pythagorean theorem. Let's give it a name. Let's call it h because it's the height of this triangle. That way, when I use Pythagorean theorem twice, I'm not super confused with the letters that I used. So I am going to use Pythagorean theorem. A squared plus b squared equals c squared. Now, looking at this triangle right here, this little one with h11 and 26, I know c has to be my 26 because c always has to be the longest side, the side opposite of my right triangle. It doesn't matter which one's a or b as long as the longest side is c. So a is h squared, so h squared plus b is 11, so 11 squared is going to equal c, which is 26, so 26 squared. H squared doesn't change. 11 squared is 121. That's going to equal 676. Now, in order to get h all by itself, I have to get rid of squared and I have to get rid of minus or a regular 121. And I do that by minusing 121. I was getting ahead of myself. Got excited there. So let's subtract 121 from both sides. H squared is going to equal 555. Square root both sides, and I have zero clue what the square root of 555 is, so I'm going to go off to the side and do that. So it's gross, and I knew it would be gross. That's kind of why I took a moment to figure out what this was, because I thought I was going to get something pleasant, and I didn't at all. It's 23.558, so let's go with 23.56. So this guy is 23.56. All right. That guy, the height. Yippee. Now, I'm going to do the same exact thing to find out this part right here. So I'm just going to call it x. All right. I am now focusing on this triangle on the left, where I have a height of 23.56, I have a hypotenuse of 42, and I'm missing a length of x. So I'm going to use Pythagorean theorem again, using different colors so I don't mix the two A, B's, and C's. I will call you A again because, why not? I'll call you B as long as I call the longest side C. So A is 32.56. 23.56 squared plus b is, x squared equals 42 squared. Before you reach for a calculator, we know what 23.56 squared is. It's 555. We just did that. Oh, yeah. Plus x squared is going to equal 42 squared, which is 1,764. Subtract 555 from both sides. Subtract 555 from both sides, and you're looking at 9. Carry the 1, make that a 2. 1209 gross is equal to x squared. Is x all by itself? No. Squared's in the way, so let's square root both sides. No clue what the square root of 1209 is, so I'm going to go off to the side. It's gross. It's 34.5 34.77067731. So I'll put 34.77. So this guy right here, and I'll make it black, is 34.77. So in order for me to find the perimeter of this whole triangle, I have to add that side plus 26 plus 11 plus 34.77. 42 plus 26 plus 11 plus 34.77. That's going to end up equaling 113.77. No units to worry about, so units, feet, inches, whatever. Just don't square it because we're not finding area, we're finding perimeter. Pretty gross problem. Not a big fan, took a while, but yeah, I got it. I got it good.